I'm Rohan, this is Nick, and we did our project on golf statistics.
Specifically, since we're both big sports fans and enjoy golf, we thought that we would try to find some interesting statistical trends in golf. There's a lot of data available for golf, so we wanted to do something that was simple and digestible. So we decided to analyze whether putting or driving was more important on the PGA Tour. And putting has historically been looked at as more important, but in the past 10 to 15 years, driving has risen a lot in popularity relative to sports data. So to start off, we got probably the backbone of our project is this giant CSV file that I found on a sports data website. Um, it's got all kinds of tournament information going back to like 2015 for players and uh, tournament purses and strokes gained, and I mean even like insurance debtors for, par three holes. So we had to clean that up a lot. I mean, we had to remove NaN values and non-values. We had to deal with, WD and cut being included in the finish column with like floats and integers. We basically had to just cut out a ton of stuff and get down to the actual stuff we wanted. But we managed to do that, and we ended up with, I think it was about 26 columns by 34,000 rows.
Yeah, and then we also got some additional data just to supplement that. So we started with web scraping, and we wanted to find data on basically just driving ability and putting ability on the PGA Tour for the past couple seasons, and we wanted to link that to actual performance on the tour. So we took their FedEx Cup points, and we ran into some problems with that just because the data we were trying to pull from the PGA website was dynamically loaded. And so when we used Beautiful Soup to parse through that, it ran into a lot of problems. But we got around that issue by just pulling all the data we wanted from multiple web pages and then concatenating that data so that we could use Beautiful Soup instead. The only issue with that was that since we were concatenating from three different web pages, there was sort of incompleteness in the data where there would be golfers who are on one page but not on the other, and we didn't want to work with incomplete sets. So when we were cleaning through these three sets of data, we just had to make sure that we had complete sets of data. And then we also pulled a little bit more data from an API. And the issue with this one was just that the API was paid. So we ended up using a free trial, but there was a limit on the number of API calls we could use or we could make. So how we got around that was by just writing a helper method to cache the data. So when we called the API, we could store that data locally to a file on our Jupyter Notebook or Google Colab. And that way, when we re-access the data, we don't have to make another API call. We can just read from the file we wrote. And when we were actually doing the cleaning for the API data, there wasn't much to actually clean with the API data itself. It's just that we were pulling data on betting odds for these golfers, and it didn't really have any data on putting or driving. So in order to actually make the data relevant, we had to go back to our CSV that we cleaned earlier and concatenate our API data with our CSV data, which took a while. And then with our actual data analysis, so our first insight, we just decided to do a simple comparison on correlation between strokes gained off the tee, which is a pretty standard measure of driving ability and tournament performance, and then compare that correlation to the correlation between strokes gained putting and tournament performance. And what we found was that at least across the tournaments we analyzed and the data set we used, putting was more correlated to performance than driving. So R squared basically just estimates or sort of the percentage of the result that can be attributed to a certain factor. And so basically it's what we found was that about 10% of the finish can be attributed to driving ability and 20% can be attributed to putting ability. And so we have our scatter plots here at the bottom, and at the bottom, all these values at the bottom of these two scatter plots are players who got cut. And so we represent them on the graph right there at the bottom. And then for our second insight, we decided to reaffirm our results from insight one just because it was sort of surprising, because the consensus in the golf community is that driving is a little more important than putting at the moment. So we decided to use the Pearson's correlation coefficient to measure correlation once again, and then also add to that by using a pair plot to find differences in the distributions of strokes gained off the tee and strokes gained putting, as well as the relationship between the two outside of finish. And so we have that pair plot here. And what we found was we were able to replicate our results from Insight 1, and we found that the correlation was greater for putting than driving. And we also noted that the distributions of putting and driving ability were approximately normal, but they did seem to be skewed to the left a bit. And we noted that, as you can see, this plot in the middle here, the variance of strokes gained putting seems to be a lot higher than the variance of strokes gained off the tee, which is something we ended up looking to later. And then we observed that there is no clear relationship between strokes gained putting and strokes gained off the tee, as you can see on that middle left scatter plot. And so we decided to take that one step further by seeing what is the actual relationship numerically between strokes gained putting and strokes gained off the tee. And so we did that in our Insight 3. We decided to check the covariance between the two. And so what we found was there's actually almost no relationship between the two, between strokes gained putting and strokes gained driving, which sort of makes sense if you think about it, because on the one hand, a better driver is going to put themselves into positions to have easier putts and to become a better statistical putter. But on the other hand, anytime you spend working on your driving is going to take away from time you can spend working on your putting. So that's sort of like a pitcher is not going to be a great batter in baseball. And so those two factors end up basically canceling each other out. And so we found that our covariance between strokes gained putting and strokes gained driving or off the tee was approximately zero. It was actually negative 0.0285. And then we confirmed our inferences earlier about the variances of driving and putting, and we found that the strokes gained off the tee had a variance of 0.63, and strokes gained putting had a variance of about 1.23.
So coming off of that data, which was actually quite surprising, a lot of modern sports statistics would say that driving and driving distance is significantly more important than, any other statistic. But there we had actual concrete evidence that putts is more important. So we decided we wanted to look at it from some other angles just to kind of double check. One way that we did was we looked at Vegas odds and sports betting. And so we checked fantasy points and we ranked players based on their strokes gained off the tee and strokes gained putting, and then categorized them based on their total FanDuel points. And then we were able to basically see public opinion on driving versus putting and how players are categorized so that we could kind of, again, see the insight behind why everyone thinks it's driver, but our data seems to show putting. And then we also looked at putts per round, average driving distance, and total PGA Tour Championship points. And that was another way to just kind of reaffirm our data. So what we did was we took the average driving distance and the average putts per round, and then we sorted for players that were significantly, above or below the mean. And we also tried to, assign those values equal statistical variations. And then we categorized players, again, based on whether they were a putter or a driver. And we were able to see the output of those results based on their total PGA Tour Championship points. And here we see the output of those. And so the FanDuel points, you can see all of the public opinion top bettors are big time drivers. And then if you look down at the championship points, that kind of makes sense because everyone in the top championship points is drivers. So therefore, we're kind of stuck in a position where, for based off insights 1, 2, and 3, it looks like putting is more important. But insights 4 and 5 show that in public perception, people think driving is more important. And then in PGA Championship points, it seems that driving is more important, which brings us to insight 6. And in Insight 6, basically, we tried to put a final, cap on it by looking at the top 10% of putters and drivers, as well as the bottom 10% of putters and drivers. And then we were looking to see how many tournaments people who were excellent in those abilities were able to win. Because you'd think that someone who's a fantastic driver is going to be the standard for how you can win as a driver player, and vice versa with a putter. And based on that, we got the results. that showed that if you're a top 10% putter, then you have a much higher chance of winning. The number of winners among top 10% putters is 115 times. They've won on tour 115 times if you're a top 10% putter. If you're a top 10% driver, which means I guess people will probably bet on you and people think that it's a very theatrical overpowering of a course, you have less odds than you do with being a top tier putter. And so, although insights 4 and 5 seem to show that driving does still play an important role, based off insights 1 through 3 and now kind of this cap of insight 6, we've shown that putting is really the most important statistic in the field, especially at a PGA level.
And also beyond that, we also found that 10% of the bottom 10% of putters and bottom 10% of drivers, a bottom 10% putter has never won a tournament, at least in over the time period we measured. And a bottom 10% driver did win one tournament, which again supports that finding that putting is more important. And then we again tried to take that one step further in Insight 7. So because of the sort of conflicting data we found between insights 1, 2, and 3 and 6, where putting seems to be more important towards winning tournaments. And then what we found insights 4 and 5, that drivers are more successful at in terms of PGA Tour championship points. We wanted to isolate the data to try to figure out if our relationship between putting and driving and finish is non-linear, where can we see where putters are more successful and where drivers are more successful. And so we broke our data into 2 categories 2 times. So the first time we said, if we look at players who made a cut and players who didn't make a cut, how do their driving and putting abilities compare? And then also if we break it a little higher and we say players who finished top 20 in a tournament versus players who didn't, how did their putting and driving abilities compare? And so what we found here was that on the left side, we have our scatter plot of players who made the cut. And we found that overall, these players tend to be better drivers than putters if they're making the cut. So people who made the cut are in orange and people who missed the cut are in blue. And you can see players to the right of 0 on the x-axis tend to be more orange than players above 0 on the y-axis. So players who are better drivers tend to be make the cut more often than players who are good putters. And we saw similar data on players who are finishing top 20. So again, obviously players who are good putters and good drivers are making cuts and finishing top 20. But of players who are good at one but not good at the other, we found data that drivers tend to be better in these 2 categories. And so that sort of supports the idea of this nonlinear relationship between putting and driving and finish, because we saw that players who are winning tournaments tend to be great putters, but players who are just making top 20 finishes, they tend to be better drivers, and players who are just making the cut, they tend to be better drivers. And we saw earlier on Insight 5 with the PGA Tour Championship points that players who are at the bottom, players who are at the top were better drivers, but players who are at the bottom also tend to be drivers as well. So it kind of suggests that drivers dominate the bottom half of bottom part and the top, but not the elite part of golfers. But great putters tend to be the ones winning these tournaments. But
that's also supported. Sorry, I don't mean to interrupt. In regards to some of that statistical data in support of what he's saying, if you look at the strokes gained off the tee, those orange dots go way further left than the orange dots putting.
Yeah.
Like generally, it's much more so that you can have someone who is a terrible driver, but then they can make it up around the greens. But it's not necessarily vice versa for making cuts. But for elite winning tournaments, it's back to what he's saying.
Right. And I think that's also something that gets supported in the variances we did in Insight 3, where we found that the variance in strokes gained putting was a lot higher than strokes gained off the tee. And that kind of supports the idea that if you're a really poor putter, that's not something you can just make up driving. But if you're a poor driver, because the spread between the worst and the best is not quite as high, that's something you can make up with elite putting ability in certain categories, in certain performances. And that supports the idea of this nonlinear relationship. And to actually hone in on what sort of relationship that is exactly, we'd have to do a little more digging. But that's something we can do in the future. And then just to wrap up what we learned in this project, so our final conclusions were that putting and driving are both hugely important, which is fairly intuitive. Obviously, they're huge parts of the game. And we also found that again that there's more variation in putting abilities and driving abilities, which makes being, like I said, makes being a terrible putter virtually impossible to recover from. But it also makes improvement in driving ability hugely consequential. So if you look back at the scatter plots, you'll find that those who are really, really good drivers, as compared to the rest of their competition, tend to do really, really well, even better than those who are elite putters, just because the difference between the elite driver and the average driver, that difference is hugely consequential in terms of finish. And then we also found that in general, putting seems to be more correlated with finish, at least of the tournaments we analyzed, which is a little surprising. But being a good driver seems to be a better strategy for avoiding the cut. So there's certain groups where being a driver might be more important. Being a good driver might be more important than being a good putter. And so because a lot of our data doesn't point too strongly to one way or the other, we found that the relationships between putting and driving and performance is probably nonlinear. But both are critical to golfing success. And with more data, we can hone in on what the actual relationship is exactly. And then as far as what we learned with data analysis and actually coding with this project, we learned a lot of packages, statistical packages and visualization packages and sort of methods we can use to do some data analysis on large data sets. And obviously we got more adept with some of the stuff we learned in class, like NumPy and Pandas and Matplotlib. And I think a lot of what we learned was that we didn't spend too much time actually doing the analysis and the data analysis, but more of thinking about how to approach the problems and trying to figure out what we were going to find and how we were going to find it. And the coding wasn't actually too tricky, but it was the collection, the cleaning, and mostly just figuring out what we were actually looking for. And then I think for us, the biggest challenge as well was simultaneously having too much data to choose from and too little to use. So we had all these categories and like Nick mentioned, we had this huge CSV with all these columns, and it's sort of difficult to pick and choose what we wanted to actually focus on. And then when we actually got something to focus on, when we focused on our strokes gained and driving distance and betting odds and whatnot, when we actually got into that, we found that suddenly we had too few observations to really be super conclusive in our analysis. And yeah, I think that was our biggest challenge, but I think we did a pretty good job of that.
Yeah, and I would add on to what he's saying just in regards to that CSV. There's so many metrics that you can use to measure golf statistics. I mean, we didn't even begin to approach strokes gained like tee to green
Mhm.
or strokes gained around the green or all the other infinite amount of things that you can use to measure progress. Like we kind of tried to boil it down to something very simple in terms of driving versus putting, but even then we got not necessarily conclusive answers. So I think that's a problem with all data. It's just that it becomes overwhelming at some points.
I don't know what else to say.
Anything else? Yeah, I mean, honestly, we did good. I I don't know. I think that was pretty good.
Okay.
I mean, because the other if we retake it, it's going to take another 15 minutes, and I don't know if the
Yeah.
quality